Hello, in this video I'm going to be showing you a visual proof of the difference of squares. So if you've been studying factoring previously and you've looked at the difference of squares, you maybe already know that the polynomial x squared minus 9 can be factored into x plus 3 and x minus 3. If you haven't seen this previously, then this demonstration will show you why that is the case. And if you have learned it as a fact that you've just memorized, perhaps this will help clarify why that fact is so. So the first thing I've started with is a square, and I'm not going to say what the dimensions are. If you wish to count and figure out what the x value is, you can do that, but I'm not going to. So the square measures x by x. And then the minus 9, I'm going to show that as I'm going to be removing a little 9 square centimeter or square object from the corner down here. So you can picture that I have the blue square has been cut out of something, and then I'm going to remove 9 square units from the bottom right-hand corner. And the remaining space here is worth x squared minus 9. So the remaining piece of this is to figure out, well, how is this shape the same as doing x plus 3 times x minus 3? So one of the first things we've got to consider is I did right away. I know that 9 is a 3 by 3, so I'm going to mark this dimension right here is 3 and 3. So that's one of the features of a difference of squares, is that each of the components, each of the two terms, are squares themselves. So this was the square of 3 makes 9. So if the entire length of the side is x, and I've removed 3 from that x, then the remaining length of this shorter piece here is, I could call it x minus 3. It's x that's been reduced by 3. And the same holds true for this other short piece right here, x reduced by 3. And in this case, my x value is 8 across, so you could do the arithmetic there in your head to say if this is 3, then this remaining length has to be 8 minus 3, which is 5. And it is. You can verify that by counting. Okay, so now I want you to consider that instead of representing this space as a square that has had another square removed from it, which is what we've got here on the left-hand side of this equation, I'm going to represent it as one value times another value. Or in other words, a length times a width. Well, length times width is a rectangle. So what I'm going to do is rearrange the pieces here of this sort of L shape. Imagine that I'm going to cut that off. And I'm going to migrate that piece and stick it over here so that I make a rectangle instead. So I'm going to have x across like that. And then I'm going to have 3 more squares there. And the height is, in this case, 5. This is x, and this is 3, and this dimension is x minus 3. And so all that I've done in this visual proof is I'm proving that the larger square minus the smaller 9 squares is the same shape, the remaining squares left over, is the same amount of space as if I take that little chunk from the bottom left and move it up to the right, creating a rectangle. So the total distance of the length of this rectangle is x plus 3. And the height of this rectangle, or in this case the width, is x minus 3. So this is the visual proof that x squared minus 9 is the same as x plus 3 times x minus 3. Let's do one more. Okay, this time, again, the x will have a different value this time. Because it's a variable, it can do that. And I'm going to show x squared minus 25. So to take 25 away from my x squared, I would need to cut out a 5 by 5 square from the corner here. So this is what I'm removing. X squared minus 25 is this remaining L shape. Okay. So now I'm going to label some more of the dimensions. 25 is a 5 by 5 square. The height of this side is total x. So when I remove 5 from that x, that's the expression for this piece that's left over, right here. We've got 5 here, and then this leftover piece is x minus 5. Again, slice off the bottom little flap there of this L, and we're going to migrate it up so that we're making a rectangle. And I've just added a little point there to help me see what I'm doing. So x minus 5, in this case, is 4 squares in my visual proof. So this is x plus another 5. That was this length here, and it's been migrated up. And the dimension of this height of the rectangle that I've got shown here is my x minus 5. So I've just shown with the visual proof that x squared minus 25 is the same as x plus 5 times x minus 5. X plus 5 being the length of the rectangle, and x minus 5 being the width of that rectangle. So this feature of plus and minus the same value, if you've been given a difference of squares, applies to all polynomials of this type.